Alright, so in state space example 2, what I want to do is again get state space given a transfer function. And the way that I'll do that is I'll start by cross multiplying. So that way what I'll do is isolate the y's and the r's. So I'll have s squared plus 5s plus 4 times y of s is equal to 4 times r of s. Okay, so then I would take the inverse Laplace transform, and what I'll get is y double dot plus 5y dot plus 4y is equal to 4r. Okay, now the next thing I want to do is assign. So let's start by saying assign in the following way. x1 is equal to y, x2 is equal to y dot. Alright, this implies that x1 dot is equal to x2, and x2 dot is equal to y double dot. So now we will solve for y double dot. And when we do so, we'll get the following. Y double dot is equal to minus 5 y dot minus 4 y plus 4 r. And then I'll sub in my states. All right, so let's sub in our states. And what we'll get is that x2 dot is equal to minus 5 x2 minus 4 x1 plus 4r. All right, so we can actually collect these into matrices so that we have x1 dot x2 dot is equal to, and this is going to be a square 2 by 2 matrix. All right, the state vector is x1 x2 plus blank r. All right, so if we collect these and we look, then we get x1 dot is equal to x2, so it's 0x1 plus 1x2 plus 0r. All right, x2 dot is y double dot, which we have come up with the equation for here. I get minus 4 x1s minus 5 x2s plus 4r. All right, so then the other thing I need to do is come up with the output equation, and you can see that I've defined the output right here to be x1 is equal to y. So my y equation is going to be similar to something we've seen in other expressions where I have 1x1 and 0x2s. And that's really my whole solution. So that, as long as we're in this form where the numerator has no powers of s, then we can do this and it's relatively straightforward.